Hello everyone, it's Mr. Wolfe here, and in this video I'm going to be introducing proportional reasoning with freefall. It's going to be really similar to a lot of the proportional reasoning we've already been doing, but there are a few new things that I want to introduce. All right, one is looking at these equations right here. All right, when we're proportional reasoning, we do not want to worry about things where you have addition. We're only going to really worry about equations that are either multiplying or dividing. So this automatically gets rid of these equations, at least written this way. Now you'll notice that these equations look really similar, and that's because they're actually the exact same equation, just written a little bit differently. All right. I'm going to go back to these in just a second, but a few other things that are going to help out with explaining what these equations are and how they're similar is this delta right here. So delta x, delta v. The delta just means change in. So if I have a delta x, it means change in position. In other words, I'm going from here to here, so it's the distance I've traveled. It could also be the height. And then therefore, change delta v means change in velocity, right? You may remember at the beginning of the year, we've talked about things. If I wanted to calculate the change in position, I could do final minus initial. Same thing with initial velocity, or sorry, with change in velocity. It's always final minus initial. All right, so with that information, let's go back up here, right? And what I could do if I wanted to rearrange this equation and I wanted to get delta, or this initial position to the other side, is I would subtract it from both sides. So it would cancel out over here, and it would almost be like x minus initial position is equal to, and then velocity constant times time. Well, final minus initial, that's delta x, right? So instead of writing it like this, I could just consolidate it into delta x. It's the same thing with initial velocity here, same thing with initial velocity here. So I'm going to use these equations for proportional reasoning, right? And you might be like, well, Mr. Wolfe, isn't there a plus sign right here? There is, but we're going to notice that almost always we're going to be putting a 0 in for our initial velocity there. Okay. Just as a reminder, when we're doing these types of problems from Unit 1, we want to always ask ourselves, are we dealing with constant velocity? And if that's the case, then we're going to be using our constant velocity equation. All right? But if the answer is no, we're going to go to our other equations right here. And in terms of which one to use, well, it's usually going to be the one, or it's going to be the one that it has the variable we're looking for and it has those other variables. But some other things that could help us out is if it's asking for or it includes distance, right, this delta x, we're probably going to be using this equation right here because this one doesn't have it. Otherwise, well, most likely if it's for instance, you have acceleration and your change in velocity and you're looking for time, you'll use this one over here. All right, so a few other things that I want to go over before we look at an example is we're going to be determining factors of change. And so if it's a free fall problem, all right, we always know that the acceleration due to gravity is negative 9.8 meters per second. So it doesn't matter if I have two different situations, that acceleration due to gravity is always going to be negative 9.8. And when we're proportional reasoning, our factor for that is 1, right? Because it's the same in both scenarios. And it will always be in free fall. If not, read the problem more, but almost always, at least for these initial problems, we're going to be looking at free fall. Okay. But then also this is new, this concept of zeros. All right, we've never plugged in zeros with proportional reasoning, so why would we do this? Well, let's say I have my scenarios again, A and B, and my initial velocity, let's say it's free fall, right? I'm dropping two objects of maybe just different masses, and my initial velocity is going to be 0 meters per second, right, in both scenarios. So a lot of students are tempted, hey, 0 meters per second, 0 meters per second, that's the same, I'm going to put a 1, but if these are both 0, we're just going to put in a 0 for initial velocity. So that's kind of going back up here, right? 0 for initial velocity. It's only when you actually have a value and those values are the same that we'll plug in a 1. But if your values are both 0, you're just going to plug in a 0. All right. So with that in mind, let's look at a sample problem. All right. A cartoon character drops a piano from the first story. The piano lands on the ground after 3.5 seconds. So I see units there, so I know that that's a real number. I'm going to make I don't have a lot of space here, but I have an actual number column. I'm going to say time is equal to 3.5 seconds. The same cartoon character then goes to the 100th floor. So that's a factor because it's 100 times higher. Right? So my height in this case is going to be 100 times more. But remember, with the problems we've been dealing with, there's no height. Right? Instead, our height is going to be the distance that object's traveling. In other words, it's going to be delta x. So my delta x is going to be 100. All right. Now a few other things. By what factor is the time and the air different? So that's what I'm looking for. Time is equal to question mark. I'm looking for that factor, which means I'm not going to be using actual numbers. All right. And then some questions that I want to ask myself. These eventually will go away. You'll just solve it. But to start off with, is this a constant velocity or constant acceleration problem? Well, if I'm free falling, this is absolutely acceleration, right? Constant acceleration compared to constant velocity, right? And then, um, am I given any or want any information about position? Yeah, right. In this case, it's the height. So we're going to be using delta x right here. Okay. And then in terms of the equation to use, well, if it's constant acceleration, that rules out our constant velocity equation. Right? And since it's including delta x, we're probably going to use this one right here. And so delta x is equal to 1/2 at squared plus initial velocity times time. All right. A few other things. What does the word drop tell us about the above variables? Well, that tells me that the acceleration for both is negative 9.8 meters per second. All right. Well, that's supposed to be a decimal. And that they both have an initial velocity of 0 meters per second because they're both dropped, right? All right. Now let's plug in the factors and solve. So here's my equation. My delta x is 100 times greater. The height is 100 times greater. It's proportional reasoning, so I do not care about constants at all. I'm not going to include them. All right. The acceleration in both cases is negative 9.8 meters per second. All right. So I'm going to put in a factor of 1 because it's the same in both conditions. Some students are like, well, Mr. Wolfe, do I need to put a negative? It's a great question, and no, you do not need to worry about a negative in this case. We're solving for time in this case, so time squared, because we're still going to include the square. And then my initial velocity, all right, in both is 0 meters per second. But remember, because this is a 0, we're not going to plug in a 1. If they're both 0, we're just going to plug in 0 for my initial velocity, even if it's proportional reasoning. All right, so now to kind of bring things together, 100 is equal to time squared. I take the square root of both sides. The square root of 100 is 10. So that means that my time is going to be 10 times as much. In other words, you increase your height 100 times, but the time doesn't take 100 times more. It's just 10 more times in terms of the time it takes to drop. All right. Now, what's the time it takes for the second piano to drop? Well, I'm going to go back to my original value, which was an actual value, 3.5